So
Okay.
so matter pops into being essentially after things cool down to some degree, and there aren't exactly different laws governing the universe before that, but the what would you say, the allowances that the current laws make have a remarkably powerful effect before that.
Yeah, yeah, absolutely. The form that the laws, I mean, the laws of physics do evolve at energy scales, and which laws are important at different energy scales are different. So certain laws of physics, even if they don't change at all, certain things are more important early on, and then other laws become more important later on. Like now, obviously, electromagnetism on small scales is incredibly important. It governs all the biology, all the chemistry, all of the things that we see in the world around us. At early times, it was nuclear physics and particle physics, the laws of the strong and weak interaction that were determining what was going on. But you're right, eventually, and it took a while, it took a long time before the universe became dominated by matter. Even when the universe was 1 second old and a temperature of about 10 billion degrees, there weren't even elements. All of the, that's the other thing that's remarkable. Until the universe was, even protons didn't exist until the universe was somewhere about a millionth of a second old. But elements didn't exist. All of the light elements, hydrogen, helium, and lithium, were, if you wish, created by nuclear reactions in the first 5 minutes of the universe, which is why Steven Weinberg's book called The First 3 Minutes talks about that. So, and those were the only elements created at the beginning of time. The smartest person there in the physics department, he's now dead, Sidney Coleman. He said the proper thing to talk about is not the interpretation of quantum mechanics. It's the interpretation of classical mechanics. Because the real world is quantum mechanical. And any classical picture we impose on it is going to be crazy. But you don't have to think of them as real. They're all just different approximations to a reality, an underlying reality, which can't be described by any classical picture. So that's why all these classical pictures seem crazy, because none of them is complete.
Well, if you look at this psychologically, I'm going to refer to Piaget again. I mean, Piaget pointed out that we derive our concepts from our practical manipulations of things. So, for example, you might ask why is this one thing? I could say, well, it's five things.
Yeah. Okay.
Well, the question is, well, what's a thing?
Yeah.
Well, look, it moves as a unit. Therefore, it's a thing. So that's one. Well, it could be five if I broke it apart. Now it's two.
Yeah.
But the concept itself is predicated on our interactions at this scale. And so we're going to derive our sense of reality from our practical interactions at this scale. And your claim, the claim of the quantum mechanics in general, is that doesn't apply at the micro scale. So our intuitions are gone because our intuitions are predicated on our embodiment at this level of analysis.
Absolutely. In fact, the purpose of The Greatest Story We're Told So Far, that particular book, is to say something remarkable. The world of our experience is an illusion. Now, I know I hate to say it because it breeds all sorts of mumbo jumbo and people start doing, but at a fundamental scale, at the small scales, everything that defines our universe, including matter and mass, really the things that make the universe we experience, are really accidents of our circumstances rather than fundamental properties of the universe. So our universe.
Yeah, well, that's something I would like, and we can do this again when we talk again, because I'm always curious about that leap into purposelessness. And one of the things I would like to ask you just briefly on that subject is, as the universe cools, we do see a gradual increase in at least one sort of important complexity, right? And that's the building of the building of the periodic table. And so atoms become more and more complex and sophisticated as the universe cools. That seems like a kind of directionality that's built into the structure itself. And it isn't, do you think is that necessarily discontinuous with the radical increase in complexity that you start to see 3.5 billion years ago when life emerges? Or is that the same process of complexification?
Well, okay, it's a good question. And the answer is it's all momentary. It's a momentary accident. It is true that the stars, as individual stars evolve, they build up heavier and heavier elements. Okay, they do it at the expense of their surroundings by increasing the disorder in their surroundings, right? They're emitting energy. and
Right.
energy. Okay, so there's no
So there's
violation of the second law.
there's localized increase in complexity, like us.
Yeah, but it's all momentary. If you follow it long enough, the heavy elements are going to disappear, matter's going to disappear, and the long term, the universe will just be pure radiation again. So this buildup of complexity, which you're absolutely sure is not a direction of the universe. It's a momentary but fortunate imbalance that will exist for a while until the universe catches up with it. And
that's a real problem in discussing concepts, isn't it? Because you can take a time scale and change the time scale, and all of a sudden the phenomena changes completely. That's what people do to themselves often when they think about the meaninglessness of their life. It's like, well, wait a second, I could make the case, and I've made this with my clients approximately, is if you're thinking on a time scale that makes your life irrelevant, that's the wrong time scale for the problem. That's the hopelessness is an indication that you're using the wrong frame.
Absolutely.
And you'd say, well, what's the proof of that? And I would say, well, the hopelessness is the proof of that. Now, you might not regard that as proof, but it's a point that's at least worth considering, because you could say, well, what good is a Beethoven symphony across a span of 1 trillion years? It's like, well, none, but why? What good is posing that question?
Yeah, exactly. Well, I couldn't agree with you more. The fact that we have, there's no obvious purpose to the universe, the fact that we and everything we've created will long be gone, that can depress you. But the opposite side of the coin, it seems to me, if I were a clinician, that I would try to argue to my clients, is that it makes every moment of that accident of your own existence special. And every instant is more special because it's finite, because it's so unique. And therefore, you're right, there may be no cosmic purpose to your existence, but you create your own purpose. I know you write about meaning, you wrote a whole book about meaning, but I would argue there's no objective meaning to the universe. We make our own meaning. And to the extent we make our own meaning, our lives are more or less valuable to us and to others around us. And so I would
I would quibble with that. And maybe it's not just a quibble, because I don't think meaning is something we create. I think it's something that manifests itself to us. Now, look, I know it's not that simple, because we do make decisions, but it's very frequently the case. And you know this as a scientist. For example, you may have a moment of insight into some phenomena. So that's deeply meaningful, but it isn't so much that is something you create, although you can seek it out. It's more like that's something that bursts on you.
Yeah. Okay. Well, it'll be an interesting question to see if we're debating semantics here or not.
Right.
I guess at a fundamental scale, and maybe we can follow this up in when we talk in my podcast, but I tend not to think that there's an objective meaning to the universe. There's existence.
Well, it may be that objective and meaning aren't well suited for one another, right? Because you could also make the case that the objective viewpoint precludes meaning as part of its operation. Yeah. And I think you can make a strong case that the scientific method is designed to exclude subjective meaning. That's actually one of its remarkable strengths, but it has a cost. The cost is, well, what do you do with the phenomena of meaning? Well, it doesn't exist scientifically. Well, that is something we could talk about for a long time, because that'll pull us into the question of whether what's conceptualized as objective reality is a sufficiently sophisticated conception of reality itself. And it isn't obvious to me that it is, because it does have this tendency to exclude the subjective by its